Hello class, in this video we're going to be looking at crashing. The learning intention of this video is for us to explore and understand the concept of crashing and for us to learn how do we find what is the minimum cost of a project. So let's go through what is crashing. We define crashing as a process where we change the times for an activity to be completed such that the overall minimum completion time is reduced. Let's say, for example, that a car takes about 4 weeks for it to be completely manufactured from start to finish. If you're going to crash, what that means is that you're going to be reducing the length of time of certain activities within the actual production line such that this overall time is going to be reduced. So that's what crashing means. There are different ways for us to reduce the overall time for an activity to be completed. So the duration of an activity can be reduced by having more staff to do a particular activity, because hiring more staff means that you can complete the activity at a shorter time span. Another way that we could reduce the time is just by having ideal weather. So if you've got more ideal weather, you might be able to move on to the second stage of the process a lot more faster. Alternatively, it could be other factors, meaning that if you've got better machinery, better equipment, you could therefore do the job at a faster rate and therefore reduce the overall time for us to complete the project. So these 3 dot points over here discuss ways in which we could reduce the duration of an activity. Let's now discuss how do we actually reduce the overall minimum completion time of a project. And this can actually be done in 2 ways. One of the ways that we could reduce the overall minimum completion time is by crashing or reducing the duration for activities that are found on the critical path. So remember that critical activities are activities in which we need to start the activities immediately, because if we delay them, then that obviously will delay and extend the overall time for our project. So by minimizing the length of these activities, we could therefore minimize the overall completion time of the project. And another way that we could do this is by crashing certain activities such that we create and develop a new critical path. And I want to talk about this in a bit more detail because this is a bit more confusing, hence why I've placed the asterisk. Let's look at 2 examples in this video. So the first example that we're going to be looking at is very simple and very straightforward. So in this case over here, what I'm going to do first is I'm going to find out what is the current minimum completion time for us to complete this project. So what I'll do is I'm going to conduct a forward scan. In this example, the earliest starting time for activities A and D are going to be equal to 0 since they've got no immediate predecessors. Since we know that activity A takes 2 hours to complete, therefore activity B can start after 2 hours. Since D takes 6 hours to complete, therefore the earliest starting time of activity E will be after 6 hours. The earliest starting time for activity C is going to be 2 plus 4, so therefore after 6 hours. And therefore, to find out what is the time for us to complete the project, we could do so by going through these 2 routes over here. So 6 plus 3 is going to be equal to 9, but if we go 6 plus 7, that's going to be 13. And when we're trying to find out what is the earliest starting time, we always take the larger value. So therefore, we're going to put 13 over here. Now that I've completed performing my forward scan, I can see that this project will take 13 hours for us to complete. I'm now also going to complete a backward scan so I can find out what is the critical path. So therefore, the latest starting time is going to equal to the earliest starting time for the final vertex. So I'm going to put 13 here as well. And therefore, the latest starting time of activity C is going to go 13 minus 3. So therefore, the latest starting time is going to be equal to 10 hours. For activity E, the latest starting time is going to be found by going 13 minus 7, which is going to equal to 6. The latest starting time for activity B can be found by going 10 minus 4, so that's going to be equal to 6. And if you minus the durations for activity A and D, then this is going to be the latest starting times for these 2 activities. So therefore, we can see that the critical path is going to be activities D and E. And as I said earlier on, the minimum completion time is 13 hours, which is found by performing the forward scan. So in this example over here, we haven't actually done any crashing whatsoever. Let's now look at what is the impact if we were to crash or reduce the length of an activity that's found along the critical path. So let's now reduce the duration of activity D. So hypothetically, let's now say that activity D was able to be crashed to 4 hours instead of 6 hours. So that could have been done by, let's say, hiring more employees to finish the job. So what we're going to do now is we're going to now perform the forward scan again so that we can find out what is the new completion time. So in this case, again, the earliest starting time for activities A and D is going to be equal to 0. The earliest starting time of activity B is going to be after 2 hours. Now that we have reduced activity D to 4 hours, the earliest starting time of activity D is going to be 4. The earliest starting time of activity C is going to be 2 plus 4, which is 6. And now if I was to find out what is the minimum completion time, this could be done by going 6 plus 3 is equal to 9, or 4 plus 7 is going to be equal to 11. And so therefore, remember, we always take the larger value. So now it's going to be completed in 11 hours. As you can see, by crashing activity D to 4 hours instead of 6 hours, the new minimum completion time is now 11 hours. So now I'm hoping that you can start to see that we can minimize and reduce the overall time for us to complete the project by reducing the length of a critical activity. Let's go through a slightly more complex example. So in this example over here, you want to build a community center and it's telling you the duration in weeks. The first question of this example is asking us to find out what is the minimum time for us to complete the project. So we do this by performing a forward scan. So by moving left to right, we know that the earliest starting time for activities A and B will be after 0 weeks, since we can start on these activities immediately. Since we know that activity A takes 4 weeks to complete, therefore the earliest starting time of activity D will be after 4 weeks. The earliest starting time for activities C and E will be after 4 weeks, since B takes 4 weeks to complete. The earliest starting time for activities F is going to be found by going 4 plus 3, so therefore the earliest starting time is going to be equal to 7 weeks. The earliest starting time for activities G is going to be found by going 4 plus 1, so therefore after 5 weeks. The earliest starting time for activities H is going to be dependent on the completion of activities E and F. So if I go 4 plus 4, that's going to be after 8 weeks. Or alternatively, I could go 7 plus 4, which is therefore going to be after 11 weeks. Remember, for the earliest starting time, we should always choose the later value. So therefore, we're going to be putting 11 in this box over here. In order for us to move on to activities I, we need to complete G and H. So the completion time of G is going to be after 8 weeks, whereas the completion time for activity H will be 11 plus 2, so that's going to be 13 weeks. Similarly, you want to choose the larger value between those two options, so therefore I'm going to put 13 here. So therefore the completion time of the overall project can be found by going 13 plus 6, which is going to be equal to 19. So therefore our answer is going to be 19 weeks for us to complete this project. Part B of the question wants us to determine the slack time in weeks for activity D. So for this question, this automatically implies that activity D is a non-critical activity, so it's not found along the critical path. So in order to answer this question, I will need to perform a backward scan so I can find out what activities are on the critical path. So in this case over here, the latest starting time is going to equal to the earliest starting time, which is why I'll put 19 in this box here. The latest starting time of activity I can be found by going 19 minus 6, which is going to be equal to 13. The latest starting time of activity G can be found by going 13 minus 3, which is going to equal to 10. The latest starting time of activity H can be found by going 13 minus 2, which is going to equal to 11. The latest starting time of activity F will be found by going 11 minus 4, which is going to equal to 7. The latest starting time of activity D can be found by going 10 minus 1, which is going to equal to 9. Now, to find out what is the latest starting time at this particular point of the project, notice how there are two ways. So what I'll do is I'm going to go 11 minus 4, which is going to equal to 7 weeks. Or alternatively, I could go 7 minus 3, which is equal to 4 weeks. Remember, when you're dealing with the latest starting time, you always want to select the smallest value. So therefore, we're going to put 4 in that box over there. And therefore, to find out the latest starting time for these two activities, just minus by these numbers here. And therefore, you should get these values. Now that I've finished performing by backward scan, I can now calculate what is the slack time for activity D. So please recall that slack or float time can be found by going the latest starting time and subtracting it with the earliest starting time. In this case over here, for activity D, the latest starting time is 9, the earliest starting time is 4, so if you minus that, therefore the float time or slack time is equivalent to 5 weeks. So what this means is that you have within 5 weeks to begin activity D without having to delay the overall time for us to complete the project. For part C, it's asking us to identify what is the critical path of this project. Please recall that critical activities are those where the earliest starting time is identical to the latest starting time. So therefore, in this example over here, activities B, C, F, H, and I are found along the critical path. For part D, it has given us some information. So it says the builders of the community center are able to speed up the project. Some of the activities can be reduced in time at an additional cost. The activities that can be reduced in time are activities A, C, E, F, and G. The question is asking which of these activities, if reduced in time individually, would not result in an earlier completion of the project. Before I answer this question, let's quickly review over a few things. Without doing any crashing whatsoever, we said that the minimum completion time for this project was within 19 weeks, okay? Now, in this question over here, it's saying that we can now crash or reduce the length of certain activities. We can reduce the times for activities A, C, E, F, as well as G. However, if you recall from the start of the video, I said that the way that we can minimize the overall time for us to complete the project is by crashing only for critical activities. In this example over here, the activities A, E, and G are classified as non-critical activities since they're not found along the critical path at all. And as a result, if you were to reduce the times for these activities, this will not reduce the overall completion time of the project. So I've answered this question by saying that activities A, C, and G are non-critical activities. Hence, completing these activities earlier would not reduce the overall completion time. And I'll use an example to demonstrate this. Let's say that I was able to complete activities G within 1 week as opposed to 3 weeks, okay? So as a result of that, if that's the case, the overall time for us to complete activities G would be within 11 weeks, right? However, in order for me to move on to activities I need to complete H as well. The earliest completion time for activities H will be found by going 11 plus 2, which is going to be equal to 13 weeks. And remember, we always select the highest value for the earliest starting time. So therefore, we will put 13 here. And therefore, the minimal completion time can be found by going 13 plus 6, which is going to be equal to 19. As you can see, by reducing this activity over here to 1 week, this doesn't actually minimize the completion time. So there's no point at all reducing the length of non-critical activities. Let's move on to part E. So for part E, it's asking us to determine the minimum time in weeks for the project to be completed now that certain activities can be reduced in time. In this question, it's saying that we could reduce the time for these activities by 2 weeks at most. And I did also say that we should only bother with reducing the length of critical activities as this will ultimately affect the time it takes for us to complete the project. So in this case over here, activities C and activities F are critical activities. So I'm going to reduce each of these times by 2 weeks. Currently, activity C takes 3 weeks, so I'm going to reduce it now to 1 week. And activities F took 4 weeks, so now I'm reducing it to 2 weeks. So now I'm going to illustrate that by labeling as 1 and 2 on our network diagram. What I'm going to do now is I'm going to complete a forward and a backward scan to identify what is the minimum completion time and what is the critical path. So in this example here, the earliest starting time for activities A and B again will be 0. Earliest starting time for activities D is going to be after 4 weeks. The earliest starting time for activities C and E will be after 4 weeks. The earliest starting time for activities F will be found by going 1 plus 4, which is going to be after 5 weeks. The earliest starting time for activities G can be found by going 4 plus 1, which is going to be 5 weeks. The earliest starting time for activities H is going to be dependent on the completion of E and F. So over here, I've illustrated what is the time taken for both E and F. Remember, we should always choose the larger value for the earliest starting time. So therefore, I'm going to put 8 in this box over here. The earliest starting time for activities I is going to be dependent on the completion of G and H. So in this case, G is completed by going 5 plus 3, which is going to be after 8 weeks. and H will take 8 plus 2, so therefore after 10 weeks. Again, you choose a larger value, so I'm going to put 10 in the box over here, and therefore the minimum completion time is going to be equal to 16 weeks. As you can see in this example, by cutting down and reducing the time for the two critical activities, so for activities C and F, we've managed to now complete the project within 16 weeks as opposed to 19 weeks. Now, it might seem that this is going to be our final answer, but before that, please watch what I'm about to do. So I'm going to now complete the backward scan, and there's a few other things that I want to talk about as well. The latest starting time of our final vertex is going to equal to 16 as well. The latest starting time for activities I can be found by going 16 minus 6, which is going to be equal to 10. The latest starting time for activity G is going to be found by going 10 minus 3, which is going to equal to 7. Latest starting time for activity H can be found by going 10 minus 2, which is going to equal to 8. Latest starting time for activity F can be found by going 8 minus 2, so that's 6. The latest starting time for activities D can be found by going 7 minus 1, which is going to equal to 6. The latest starting time for this particular point over here can be found by going two ways. So you can go 8 minus 4, which is going to equal to 4, or 6 minus 1, which is going to equal to 5. Again, you choose a smaller value, so I'm going to put that into this box over here, and I'm going to minus it by the other two values, so therefore that's going to be my answer. For this question over here, I know you're not trying to find out what is the critical path, but now after that I've completed the backward scan, I can now draw a critical path. And in this example over here, now that I have reduced time for activities C as well as F, a new critical path can now be drawn. So in this example here, this is now going to be my new critical path. Since we have now created a new critical path, this would now imply that activity E is now considered to be a critical activity. And because activity E is now considered to be a critical activity, we should therefore reduce the time it takes for this activity to take place to therefore minimize the completion time of the project. In the question, I am fully aware that I am able to reduce each of these activities by 2 weeks. However, in this question, I'm only going to be crashing activity E by 1 week. So from 4 weeks originally, I'm going to reduce the time to 3 weeks. And I want to show you why I'm doing this as opposed to reducing this by 2 weeks. So firstly, I'm going to now put this as 3 weeks. And what I'll do is I'll now perform the forward and backward scan to find out the new minimum completion time and the new critical path. I'm not going to go over as to how I'm going to obtain these numbers because by now you should be able to do this by yourself. So if you did this successfully, this is what your activity network should now look like. According to our network, you can see that the new minimum completion time is within 15 weeks after we've crashed E to 3 weeks now. In terms of the critical path, I could see that one of the critical paths is by going through activities B, E, H, and I. But as you can see, there's also another critical path as well. In this example, another critical path is by going through B, C, F, H, and I. And in this case over here, you're still going to end up with the exact same completion time, which is going to be 15 weeks. Let me now show you why is it that we shouldn't reduce activity E by 2 weeks. So let's now say that activity E has been reduced by 2 weeks. So now the length is now completed within 2 weeks duration. So I'm going to show that over here. Again, I'm going to now perform the forward and backward scan. So if you've done this successfully, this is going to be your answer. As you can see, by reducing activity E by 2 weeks, we didn't actually change the outcome at all. It's still going to be completed within 15 weeks. As a result, there really is no point to reduce activity E by 2 weeks since it does not reduce the overall completion time, and normally if you were to reduce an activity, this will incur more costs. So therefore it's best to just reduce activity E by 1 week. And this is going to be related to part F of this question. So part F of this question says, determine the minimum additional cost of completing the project. Since the completion time is the same if you reduced activity E by 1 week as opposed to 2 weeks, it is more cost effective for us to reduce activity E by 1 week. As a result, the overall number of weeks that we've reduced is 5 weeks in total. And to therefore find out what is the cost, since 1 week is 5,000, therefore 5,000 multiplied by 5 will give us an answer of $25,000. So this is the extra amount of money that we need to pay to reduce the overall completion time from 19 weeks to 15 weeks. By now, I'm hoping that you're starting to understand what crashing is and how we could find out what is the minimum cost for our project when crashing is involved. I would now like you to answer the following questions from exercise 15E to get further practice. This is the end of the video. Thank you guys for watching, and I'll see you guys again in the next one. Bye.